Hey everyone, how you guys doing? I hope you guys are doing great. Once again, I'm so sorry that I couldn't be with you all to review this in person, but this is the next best thing I could do is prepare a video for you guys so you can follow along. Remember, the objective here is not for you to simply copy these questions and the answers and just turn them in if this is being taken up for grading, but it is for you to attempt the problems first. And once you've done that, you can check your answers using this key. And so it begins. Feel free to pause and rewind as many times as you need. But for now, let's just dive in. So question one, simplify the expression, write your answer in standard A plus BI format. So this is the standard form of a complex number. Literally, this is telling you to add. So you just combine like terms. 6 plus 7, these two are like terms. You end up with 13. 3i minus 8i, these two are like terms. You end up having negative 5i. That's it. Question one's done. Question two is a subtraction. And remember, folks, if you have a negative sign right before a parenthesis, be very, very careful because you need to distribute that negative into both of those guys. And that's going to change their signs, right? So now we'll have 9 minus 2i, nothing changed on the first one, but this one will be minus 1 and then plus I. Okay, now let's simplify this. Look for like terms. The 9 minus 1, that becomes an 8. Then negative 2i plus I becomes a negative I. And that completes that question. Okay, let's move on to the third one. All right, this time we are multiplying these. So remember how to FOIL? You take the first digit and you multiply both of those by it. And once you do that, we'll take the second digit and repeat that process. And lastly, we'll combine like terms. So 3 times 3 becomes a 9. 3 times negative 2i becomes a negative 6i. 4i times 3 becomes a 12i. 4i times negative 2i becomes a negative 8i squared. Now, as far as like terms are concerned, you guys can already see these are like terms. That's cool and all. But remember, there's also something to be said about this I squared. So I'm going to pause here for a second to remind you guys of a little saying that we had. We said I won. And we came up with this to help us remember I to the power of 1 is I. I to the power of 2 is negative 1. I to the power of 3 is I. Negative I should say, and I to the power of 4 is 1. So where did I1 come from? It came from here. I1. And we said we put the two negatives in the middle. So remember, these two are going to be the negatives. So with that said, we then know that we can simplify the I squared because I squared is a value. I squared is negative 1. So this part here is negative 1. This really here is negative 8 times negative 1, which becomes a positive 8. So let me write this down on this next step. So we have a 9. We are combining negative 6i plus 12i. That's going to be a positive 6i. And then negative 8 times negative 1 is a positive 8. And we still have like terms. The 9 and the 8 can be added together. So the final answer here then becomes 17 plus 6i. I hope that makes sense. If it doesn't, just pause this video, rewind, and watch it as many times as you need to. Okay, so moving on to the next question. I'm going to use a different color here. So there's contrast. I'm going to draw a line here too. So remember one thing, folks. I'm going to cross out this 4. We are not allowed to ever have I on the denominator. That's a big no-no. So first of all, let's enclose these in parentheses. How do you fix this? All you do is you multiply by the conjugate. The fancy word conjugate simply means for the denominator, you'll keep the digits the same, but you're going to change the sign that's between them. So the conjugate of 3 plus I is 3 minus I. And if you multiply the denominator by it, you've got to do that same exact thing to the numerator. So let's finish this out. Now we are foiling. Again, you learned how to FOIL in the previous question. Just multiply this thing out. We're going to have 6 minus 2i minus 3i plus I squared. That's the numerator. We'll simplify in just a moment. Let's follow the denominator. We'll have a 9 minus 3i plus 3i minus I to the second. Once again, just a quick reminder, we know that I squared is really a number. Remember from I1, we know that I squared is negative 1. So we'll replace these with a negative 1. Okay, so let's now just do that. We end up having 6. I'm going to combine these like terms right here. The negative 2i minus 3i is negative 5i. This I squared, again, is a negative 1 over the denominator. So we have the 9 combining these like terms. Negative I plus 3i is simply gone because negative 3i plus 3i, those cancel out. And we're replacing this I squared with a negative 1. So it's 9 minus a negative 1. So to fully simplify this, I have a 6 minus 1, which becomes a 5, minus 5i. And on the denominator, I have a 9 minus negative 1, which becomes a 10 because these become a plus. And now this looks as though it might be the final answer, but not so fast. Always pause here to check to see if you can simplify further. And in this case, you notice we have a 5 here, a 5 there, and a 10 here. And those three numbers have something in common. The GCF of those guys is 5. So 5 goes into all of them, which means we can divide all of these by 5. So 5 goes into 5 once, 5 goes into 10 twice. So for the final answer, we have 1 minus I over 2. So this is acceptable, but some teachers really want this in, what's it called, standard form fully, like, and you would write it as 1 over 2 minus 1 over 2i. So could you ask your teacher if she wants this or this? They're both correct, but it depends on what the teacher wants. All righty, moving on to the fifth question. Okay, so again, you are not allowed to ever have I on the denominator. So how do you fix this? This is a monomial, by the way. See how we have one term compared to the previous problem where we have a binomial with two terms? When you have a monomial, you're going to multiply just by I. If you do it on the denominator, guess what? You've got to do that same thing on the numerator. So times I up here also. In fact, I like to write I at the beginning because if it's just a numerator, it looks better. I feel like it looks better that way. So now we just distribute, right? So 5 times I, 5i, plus 2 times 2i times I becomes 2i squared. Yes, we'll simplify that in a moment. And on the denominator, we have 5i squared. Folks, I know you probably have heard me say this 1,000 times. I squared is a number, right? So remember to, simplify fully. So we'll replace the I squared with a negative 1, right? So this will be 2 times negative 1, basically. And then it will be 5 times negative 1. So we end up having a 5i minus 2 over negative 5. But guys, remember, you do not leave the answer in the wrong format. Remember, the format calls you for you to write it this way. You have to have the number first, and then the imaginary component has to be last. So this is out of order. The 5i should not be leading. It should be after. So to fix this, just move things around, right? So we'll have negative 2 plus 5i, all of this over negative 5. And quite frankly, I don't like that we have a negative down here. We should really simplify this even further. Let me move it back here so we have more room. So negative 2 plus 5i over negative 5. So yeah, it's not wrong, but it's weird to leave your answer with a negative on the denominator. So what you do is something really simple. Just change all the signs to the opposite sign. So this will now be a positive 2 minus 5i over 5. So this is really the correct answer. But like I said earlier, your teacher might be wanting you guys to simplify this fully to standard form, which would be 2 over 5 minus 5 over 5i. But if you look closely, you see this 5 over 5? That just simplifies to a 1. So I'm going to change this to a 1i or just I. So either of these is correct. So ask your teacher, do you want this or do you want this? Miss Palmer. Okay, so let's move on to the next question on the line here. This is foiling. So we're taking the 3 and you're timesing it both to the 3 and the negative I. So that becomes 9 minus 3i. And then you take the I times the 3 and then times it by the negative I. So we end up having a positive 3i and then minus I to the second. Combine like terms. Also notice that I squared, we know that's a number, right? So that this is really negative 1. So what's going to happen, we still have a 9. These are like terms, negative 3i plus 3i, those just cancel out. But then here we have minus negative 1. So this ends up becoming a 10 for number 6. Moving right along. This is about simplifying radical expressions. Folks, please remember this. If you have a negative inside of the radical, it brings out an I. So you take out an I. That's a weird looking I. Let me fix that. Take out an I, and then that leaves you with a positive version of that number. So I square root of 81. And thankfully, you know the square root of 81. It's a perfect square. So this becomes 9i. That's the end of that problem. Simple, short and sweet. So if you have a negative under the radical, bring out an I and just proceed as you normally would. Now for the next question. 45 can be broken down. The cheat code that I gave you guys is find two numbers that multiply to equal 45. However, this is the caveat. We don't want any random factors of 45. We want one of those numbers that multiply to 45 to be a perfect square. That means it needs to have a square root. So the numbers that multiply to 45 are 3. I never start at 1. 1 is pointless. 2 doesn't go. 3 and 15, but neither of them has a square root. So I'm going to toss that. And then we have 5 and 9. Oh, that's a good pair because 9 is a perfect square and 5 is not. So we'll do 6 on the outside. I'm going to rewrite this 45 as 9 times 5. Now remember, we know the square root of 9, right? So we can pull out the square root of 9. What is the square root of 9? It's 3. So the 3 goes out. And once that 3 is out there, it's going to multiply what's already out here. So these are going to be multiplying. 6 times 3 is 18. And of course, that leaves you with a root 5 underneath the radical. That's number 8 for you. Proceeding. Question 9 is really, again, adding two radicals. Thankfully, each of these has a square root. The square root of 64 is 8. The square root of 100 is 10, right? So you just add these together and you have 18 as your answer. Moving right along. Probably the easiest one we've seen so far, huh? Okay, so let's continue. Question 10 here is, again, we have a negative under the radical, so that allows us or demands that we pull out an I, and then that leaves us with a 1 over 4. Now, remember what I told you guys. You're welcome to, if you want, you don't have to do this. You're welcome to literally give the numerator its own root and the denominator its own root. So you go, oh, that's just the square root of 1. It's a 1. The square root of 4 is 2. So that's really just 1/2. And don't forget the I. And that is it. On to a new topic, which is solving quadratic equation using the factoring method. So we talked a lot about this, and we said if you have a trinomial, the first thing you want to check for is GCF. In fact, not just the trinomial, you always look for GCF first. Okay, so we don't have a greatest common factor for this. So then we look and go, we have a trinomial, and we said when you have a trinomial, you want to try the X games first. We were doing product and sum. Product is the A value times the C value. Sum is the B value. Remember, A is the number attached here at the very front, and C is the constant, just the number there. So in our case, A is 1, B is 5, C is negative 36. So the product for us will be negative 36 because 1 times negative 36, and our sum is 5. Now the question that we ask ourselves is this: which two numbers do we multiply together to get negative 36. And then when we add them together, we get a positive 5. Hang on, my computer's running hot, so I'm going to turn off the camera for a second. Give me a second. All right, you guys. So we now need to find two numbers that we multiply together to get a negative 36. And when we add those same numbers, we get a 5. So if you're like me, you're going in order. You're going, what times what gives me 36? 1 times 36. But those will never add up to 5. So toss it. 2 times 18. Yeah, never add up to 5. 3 times 12. Never add up to 5. 4 times 9. Ooh, that's looking promising. There's a way to get a 5 out of those. So we know that the correct pair is 9 and 4, but now we need to account for the signs. We wanted the product to be a negative number, means one of these must be a negative, and then when we add them, we should get a positive 5. So that means we have to make the 4 a negative. So let's check it. 9 times negative 4 gives us the negative 36 that we wanted, and then 9 minus 4 gives us the 5 that we wanted. So that's the pair that you were looking for. Now that we have it, we're going to come over here and go, okay, it'll be x plus 9 and x minus 4. Now, since we're being asked to solve, remember solving is one extra step after you factored. What we just finished now, this is factoring. We're being asked to solve, and remember, it's just one extra step where you set each of your factors equal to 0, and you literally just solve using algebra. So here you would be subtracting 9 from both sides. Here you would be adding 4 to both sides. So these are canceling. So x equals negative 9 for this. Here these cancel, x equals positive 4. So those are your solutions, negative 9 and 4. Okay, so you would be doing the same thing for the next question, okay? You need to, first of all, just do the x method. Do you have GCF? Is there anything that goes into all three of these terms? If you said no, then you are correct. We'll just do product and sum. So we have product is 12, the sum is 7, because the A value is 1, B value is a 7, and the C value is a 12. Okay, so now we need to find numbers that when multiplied will give us a 12, and then when we add them, we get a 7. If you want to go in order again, 1 times 12, it's not going to give us a 7 when you add. 2 times 6, not going to give us a 7. 3 times 4, there you have it. So the values you're looking for are 3 and 4. And they do work. 3 times 4 is 12, and 3 plus 4 is 7. So we don't have to do any extra or change any signs or anything like that. So let's proceed. This then becomes x plus 3 and x plus 4. Once again, if the instructions were just to factor, we would stop there. But we are being asked to solve. So remember, you just set each of your factors equal to 0. X plus 3 equals 0. X plus 4 equals 0. And you're going to do the math for this. So subtract 3 from both sides. Subtract 4 from both sides. So now your final answer will be x equals negative 3 and x equals negative 4. Those are your answers right there. So you might have noticed question 11 and 12 is what we call the friendlier version. And this is the friendlier version because the leading coefficients, the A values were 1s. So life is really good when the A value is a 1. It's not really that bad. When the A value is 1, life is good. However, you look at question 13 and 14 and you discover this is the not so friendly version because the leading coefficients are not 1s. But don't worry, I'm going to walk you through these. And I want to remind you the process is exactly the same. Just there's going to be one tiny, tiny little difference. Okay, so first, always look for GCF. Does this problem have a greatest common factor? Nothing goes into all three, so the answer to that should be no. So if you say no, you are correct. So A is 4. You don't have to keep doing A, B, and C. I'm just doing this for the benefit of people who may not understand this. And this is probably the last time I'm going to do A, B, and C. So we'll do the X method. So see, the process is exactly the same. Here we have product. Here we have sum. 4 times negative 3 is negative 12. And then the sum is 4. So what numbers work? What numbers do we multiply together to get a negative 12? And when we add them, we get a 4. If you're thinking 6 and -2, you are correct. So then you're going to come over here and we're going to say this is going to be x plus 6 and x minus 2. But folks, be careful here because this is not the friendly version. What you do here is you're going to divide, because the a value was not a 1, you're going to divide each of these numbers by that a value, divide them by 4, and simplify the fraction if it's possible. So this simplifies to a 3 over 2. This simplifies to a 1 over 2. But recall, we can't leave the fraction there. We have to drag this 2 and drop it at the very beginning of that. And again, you're going to drag this. You're going to drop it right there. So now to write this answer out, you're going to have 2x plus 3 as a first factor. And the second factor is 2x minus 1. And again, since we're solving, we have to set each of these equal to 0. So 2x plus 3 equals 0. And 2x minus 1 equals 0. You're going to use algebra again to get x by itself. So subtract 3 from both sides. Add 1 to both sides for the other one. Right? So here, you're going to end up having 2x equals -3. And here, you're going to have a 2x equals 1. And last but not least, you're going to divide this side by 2 to get x by itself. This side by 2 to get x by itself. Now I'm going to write, since I ran out of the room, I'm going to write the answer up here. So x ends up being -3 over 2 for one of the answers. -3 over 2. And the other answer is x equals 1 over 2. Boom. So the not so friendly version literally uses the same step as the other ones, but you have to remember to divide by the leading coefficient. So let's do one more. Let's work on question 14. Once again, we need the x method. So product here is 30. Sum is -13. So what numbers do we multiply together to get a 30? And then when we add them, we get a -13. You might be wondering. Those numbers are 10 and 3. But we need for both of them to be negatives. So now we have the numbers. It'll be x minus 10 and x minus 3. However, remembering the leading coefficient is not a 1, this is the not so friendly version. We then come back and divide by that a value, which is a 5 here and here. We got lucky. This time, the 10 divided by 5 is divisible, so that's simply going to be x minus 2. This one, the next one is not divisible, but remember, all you do is drag the denominator 5, and drop it right here. So then that's going to become 5x minus 3 equals 0. Since you're solving, you're going to set each of your factors equal to 0. And then you're going to use algebra to solve. So here you're going to add 2 to both sides. X equals 2. And on the other guy, you're going to add 3 to both sides. Move this up a little bit. Alrighty, and those cancel. So you have 5x equals +3. Divide both sides by 5, like that. X ends up being 3 over 5. So you have this and you have that. Those are your two answers. Okay, so the next question is asking you to solve these equations using the, square root method. This is probably most of you guys' favorite. And we start off by just subtracting 8 from both sides. Those cancel. So 7x squared equals 7. The next move is you're going to divide both sides by 7, like so. So we end up having x squared equals 1. Now you want to get x by itself, so what you have to do is square root both sides. Now remember this, once you solve by square root, you need to do the plus or minus 1. So your answer is +1 and -1. Okay, let's try the next question. Add 27 to both sides. Those cancel. So 3x squared equals 27. And then you're going to divide both sides by 3. So we end up having x squared equals 9. Now you're going to have the square root. X equals plus or minus 3. There you have it. Okay, on to question 17. This one's actually less work than the previous one. Divide both sides by 9 to begin with. You end up having y squared equals 7, right? Now you want to square root both sides, square root, square root. Well, 7 doesn't have a square root, and we can't break it down further, so we leave our answer as plus or minus square root of 7. It's perfectly fine like that. Next question, you might have already figured this out, but subtract 10 from both sides. X squared equals 28. You know, you want to square root both sides. Square root and square root. You end up having x equals 2 root 7. Plus or minus, of course. Don't forget the plus or minus like I did. So x equals plus or minus 2 root 7. If you're wondering how I got it, I got the 2 root 7. Maybe illustrate that real quick. The square root of 28 can be broken down further. Two numbers that multiply the square root of 28, one of them has to have a square root, are 4 and 7. So the square root of 4 is a 2. That's how the 2 ends up going outside of the root, and you're left with a root 7. That's how I have a 2 root 7. All right. Next question here is, let's see. Solve using the quadratic formula. So this guy here, the quadratic formula is x equals negative b plus or minus long square root b squared minus 4ac, all of this divided by 2a. So before you start solving, you set the equation equal to 0. Every equation that's not already equal to 0, set it equal to 0. So here, let's start off by subtracting 63 from both sides. So our equation is x squared plus 2x minus 63 equals 0. And that enables us to actually figure out a, b, and c for this equation. A is 1, b is 2, and c is negative 63, which we can then plug into the equation, the quadratic formula. So let's see if we can do that real quick. All right, so I'm going to start off by doing negative b. So negative 2 plus or minus square root of b squared, and b is 2. So 2 squared minus 4 times the a value is 1 and the c value is negative 63. All of this is going to be divided by 2 times 1. Okay, and now we just simplify this. So negative 2 plus or minus square root. So you have a 4 in here. And then this is the part that I really, really need you all to be careful about, because most people make a mistake. I'm going to highlight this and maybe, let me use this color to highlight it. When you're multiplying, please make sure that you are multiplying these 3 digits. Include the negative 4. So make sure that it says negative 4 on your calculator. That is negative 4 times negative 4 times 1 times negative 63. So please make sure that you are multiplying by the negative that's right before the 4. Most people forget that. So this will end up being a positive number. So if you've already multiplied, that's good. Come on, go back to the pen here. Yeah, so negative 4 times 1 is negative 4. Negative 4 times negative 63 is positive 252 over 2. Then I'm running out of room. I'm going to move it up here. So we have a negative 2 plus or minus square root of 256 over 2. Well, guess what? 256 is a perfect square. It really is 16. So we have negative 2 plus or minus 16. Divide this entire thing by 2. Negative 2 plus 16 is it's actually positive 14 divided by 2. Negative 2 minus 16 is a negative 18 over 2. So our two answers are x equals 7 and x equals negative 9. There you have it. These are the two answers to that question. Okay, well, let's try the next one. Draw a line here so there's like a difference. I'm going to move it all the way down, maybe actually up to here. Okay. So again, the first step is to set your equation equal to 0. That's the first step. So we need to subtract 10x from both sides. Subtract 10x. So we end up having 8x squared minus 10x equals 0. Now, since we are having to use a quadratic formula, our a value is 8, b value is negative 10, and the c value, which you can't see here, is a 0. If you don't see a term, just know that it's a 0. So let's plug this into the quadratic equation. So negative b, so negative 10 becomes a positive 10 plus or minus the square root of b squared. Now be careful here. If you have a negative number and it's being squared, you better put that in parentheses in your calculator. If you don't use the parentheses, it's going to be wrong. 4 times a, which is 8, and c is a 0, right? So times 0. All of this divided by 2 times the a value, which is an 8, right? So now we clean this up. We end up having a 10 plus or minus square root of 100. But then notice, like I told you guys earlier, this part right here, negative 4 times 8 times 0, that's just going to be a 0. That just disappears. It's gone. So all of that is going to be divided by 16. Again, running out of room, so I'm going to move this up here. So we have 10 plus or minus, well, the square root of 100 is 10 over 16. Let's finish this problem up. So the first part, 10 plus 10 over 16. So we have x equals 20 over 16. Yes, we'll simplify that in a moment. The second answer is 10 minus 10 over 16. So we have 0 over 16. So our final answers are 5 over 4. And the second answer is 0. There you have it, your two solutions right there. Okay, moving right along. These next two, it's the same concept, just over and over and over again. Move everything to one side because you have to set the equation equal to 0. I want to remind you this. Never make the thing that's squared a negative. So rather than subtract x squared, which would make it a negative, we don't want to do that. We'd rather move both of these guys to the left side. So I'm going to add 8x and add 15. So what's going to happen on this right side, they're going to cancel out, and we're going to have x squared plus 8x plus 15 equals 0. Now we can do a, b, and c. A is 1, b is 8, c is 15. So the quadratic equation, negative 8 plus or minus square root of b squared minus 4 times a times c. All of this divided by 2a. Let's clean this up. Negative 8 plus or minus 64 minus 60. All of this divided by 2. Moving on to this little space here. So we have negative 8 plus or minus square root of 4. All of this divided by 2. Thankfully, we know that 4 has a square root. It's negative 8 plus or minus 2 over 2. Now to finish this off, we have negative 8 plus 2, right? So that becomes negative 6 over 2. And then we have negative 8 minus 2, which becomes a negative 10 over 2. So to finalize this, it'll be x equals negative 3 and x equals negative 5. Those are the two answers that we get from this question. Okay, the last one, once again, pretty similar. So I'm going to have you guys just try that on your own, actually. Question 22. Well, you know what? I'll just go ahead and do this so you guys are not left stranded. All right, A, B, and C. A is 1, B is negative 8, C is 5. So working fast, negative B is negative 8. So it becomes a positive 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 5. All of this divided by 2 times 1. So we then have 8 plus or minus 64 minus 20. All of this divided by 2. So we end up having, and move this over here, we have 8 plus or minus square root of 24 over 2. And we've got to simplify this square root of 24. We can't leave it like this. So remember, we learned how to simplify radicals. This square root of 24 breaks down to 4 times 6, which then breaks down to 2 root 6. So I'm going to rewrite this as 8 plus or minus 2 root 6 over 2. And you look carefully, you're going to notice 2 goes into all of these. 2 goes here and also here. 2 goes here 4 times, 1 and 1. So a final answer, which I'm going to write here, is 4 plus or minus square root of 6. Oops. X equals 4 plus or minus root 6. There you have it. Now the next method is solving using the completing the square method. So let's use this color again. So when you're completing the square, y'all, remember it's a bunch of steps, okay? So step 1, move the constant to the right. If it's not already moved to the right, that's your first step. Move the constant to the right. So we do that by subtracting 5 from both sides. Now, as I move that to the right, notice that I'm going to leave some blank spaces. So it's going to be this. It's going to be x squared minus 6x plus a blank space equals -5 plus a blank space. Quickly reminding you guys here that to fill the blanks, this is step 2, to fill the blank, you use b over 2 squared. So for this question, the b value is 6. 6 divided by 2 is 3. 3 squared is 9. So that's going to be a 9. And if you put the 9 there, well, you have to put the 9 on the right side, because whatever you do to the left side, you got to do to the right side also. So the right side is easier to simplify because it's just -5 plus 9. And that's just going to be a 4. On the left side, I've got great news for you. You can always set up a parenthesis squared because it's always going to factor nicely, just like that. And to fill the blanks in here, always copy that first sign, right? So the first sign for us is a minus, which means we're going to have a minus in here. And then the other blanks, you literally just take the square root of that first term and the square root of the last term. Square root of x squared is x, and square root of 9 is 3. So that's fully factored. Now we can try to solve for this. You can solve for this by taking the square root of both sides. The reason you're doing this is so the squared and the square root cancel, leaving you with just the x minus 3 under the radical. Equals plus or minus 2. Square root of 4 is 2, but then since you're solving, you have to remember to account for that plus or minus. To get x by itself, you're going to add 3 to both sides like that. And watch, those are gone. Notice how I write this. X equals 3 plus or minus 2. Very intentional because I want to be able to finish this off. I can literally add 3 plus 2 is going to give us the first answer, right? Because hopefully you guys can see that 3 plus 2. So the first answer is x equals 5. And the second answer is 3 minus 2, which happens to be a 1. So those are the two solutions. Okay, so let's do another one. Let me get some water first. I'll be back shortly. Okay, so here's the next question. Again, just to remind you, we are solving using completing the square method. As you know, we always move the constant to the right. Thankfully, that's already been done for us. The constant is already on the right side, so we don't have to do that step this time. However, the big problem is you can only complete the square when the leading coefficient is a 1. So we have a big problem because it's currently a 2. But don't worry, all you need to do is remember the first type of factoring, or rather the first factoring method we always look for is GCF. When you examine this closely, you'll notice, oh, wait a minute, 2 is the greatest common factor. So we can take that out, which leaves us with x squared minus 8x equals -30. And then next, we're going to have to get rid of this 2. And we can do so by dividing both sides by 2, like that. So now let's proceed. These 2's are going to cancel, of course. So you'll now have x squared minus 8x. You can add that blank now, equals negative 15 plus the blank. The negative 15 came from this, negative 30 divided by 2. Okay, so remember, to fill those blanks, you always do b over 2 squared. So b value here is 8. So 8 divided by 2 is 4. 4 squared is 16. So we have a 16 over here and a 16 right there. We're just going to continue working this out. The right side, again, is easy. It's negative 15 plus 16. That's just going to be a 1. On the left side, remember what we said. These are always factoring neatly. So you can always set up a parenthesis squared. You always copy the first sign. So this time it's a negative, so it's going to be a minus in here. And then you fill the blanks here by taking the square root of that first term and the square root of that last term. So that's going to be x, and this is going to be a 4. And then since we're solving, the next thing we need to do is take the square root of both sides. Square root like that. And now you have x minus 4 equals plus or minus 1. Last but not least, you're going to add 4 to both sides. We have x equals 4 plus or minus 1. So x equals 5 and x equals 3. Those are the two solutions to that problem. Okay, so these two also require you to use the same method, completing the square. So we need to move the same process, folks. We need to move the constant to the right. So start off by adding 42 to both sides. Now those of course cancel. We end up having 3x to the second minus 18x equals 48. Another big problem, we cannot complete the square unless the leading coefficient is a 1. Thankfully, when you look at these, we have a greatest common factor of 3, which means we can take out a 3, factor out a 3, which leaves you with x squared minus 6x equals 48. But again, we are lucky because we can actually get rid of this 3 by dividing both sides by 3. So now our equation, of course, those 3's cancel. So our equation is now x squared minus 6x. Look, I'm going to leave that blank now, equals 16 plus blank. 48 divided by 3 is 16. Okay, so how do we fill the blanks? At this point, I'm sure you guys already remember this. You always say b over 2 squared. So our b value is a 6. 6 divided by 2 is 9. Is 3. 3 squared is 9. So 9 there and 9 here. And we just proceed. The right side is the easier one, so we just go ahead and add these two together. 16 plus 9 is 25. The left side factors neatly every single time, so that's going to be something squared. Always copy that first sign. It's a negative. Fill the blanks with the square root of the first term and the square root of the last term. Very good. Now we're going to go ahead and try to solve for x. Square root both sides. So we end up having x minus 3 equals plus or minus 5. To finish this off, you're going to add 3 to both sides like that. So those are gone. So x equals 3 plus or minus 5. But we can actually finish this off by saying x equals 8 because 3 plus 5 is 8. And x equals negative 2 because 3 minus 5 is negative 2. Those are the answers to question 25. So the next question, question 26. Same process. Move the constant to the right. Start off by adding 83 to both sides. Those are gone. The left side, they have a 10 in common. I'm going to factor it out. We have x squared minus 2 equals positive 80. Next step is divide both sides by 10. So what do we now have? X minus 2x plus blank equals 8 plus blank. Oh, I forgot the x here. I'm sorry. That should be 2x, not just a 2. So now let's fill the blanks using b over 2 squared. So b is a 2 this time. 2 divided by 2 is 1. 1 squared is 1. So 1 and 1. The right side is the easier one. So 8 plus 1 is 9. The left side always factors neatly. We have a minus in between them. I forgot the x squared. What am I doing? I forgot the x squared there. I'm so sorry, folks. Catch up with me on this. And then we use the square root of that first term. It's going to be an x. The square root of 1 is just 1. And then the last thing we're going to do is square root here, square root there. So we then have x minus 1 equals plus or minus 3. So I'm adding 1 here, adding 1 there. Those are gone. So x equals 1 plus or minus 3. But of course, this is workable. So x equals 1 plus 3, which is a 4, and x equals 1 minus 3, which is a negative 2. And those are your two solutions to that question. So moving on to the next concept. Here, it's simplifying exponents. So we need exponent rules. It says simplify each expression and state the rule used or rules used. So the multiplication property, remember, if you're multiplying numbers that have the same base, all these have the base of f, you keep the base and you literally just add the exponents. So again, if you're multiplying numbers that have the same base, and yes, these are being multiplied, you keep the base and you add the exponent. So it'd be negative 3 plus 2 plus negative 3. Let's simplify this. Negative 3 plus 2 is negative 1. Negative 1 minus 3 is negative 4. So please remember, never leave your answer with a negative exponent. That's going to be marked wrong always. Thankfully, to fix this is super easy. You simply move the thing that has the negative exponent. But first, let me remind you guys, there's an invisible 1 underneath this. So it's really this is f to the negative 4 over 1. So you're going to have to move this entire thing to the denominator. And when you do that, it's going to make the negative exponent a positive. So you will have 1 over f to the power 4. So you don't leave the numerator blank. So this should be your answer to this question. But now we can state the rules. So the first rule we used is the product rule. Product rule, because we applied it here. And then the second rule we've used is the negative exponents rule. So those two. Okay, question 28. Let's continue with this. I'm going to draw a line here so this is not confusing. All right, so remember, it looks like you have a lot going on, but this is pretty simple if you just focus on like terms. So just focus on the numbers alone. We have 2's, then we have A's, then we have B's, and we have C's. So we'll just consider one thing at a time. So don't be overwhelmed by this, one thing at a time. Starting with a negative 2 divided by 2, well, that's just going to be a negative 1. Simplify this fraction, negative 2, just simple math. Negative 2 divided by 2 is negative 1. Okay, so moving on to the A values. So we have A squared divided by A squared. In this case, we have, if you have the same base and we have the same base with A's and they're being divided, you simply subtract the 2. Subtract the bottom one from the top one. So it would be A to the 2 minus 2. Then we can move on to the B's, right? B's here, again, they have the same base, so you keep the base and you subtract the bottom one from the top one. Now we're going to move on to C's. And by the way, there's an easier way to do this, but I'm showing every step like this so I don't lose some of you guys. Keep the base is C, 0 minus 7. You subtract the bottom one from the top one. And now let's simplify this entire thing. We have a negative 1 still. A to the 2 minus 2, that's going to be A to the power of 0. And then B to the first, because 3 minus 2 is 1. And then C to the negative 7. I'm taking a longer route, y'all. So if you're able to do this in fewer steps, that's great. I'm only showing every step because I know I might lose a few of you guys. Anything to the power of 0, right, is a 1. So we know that this is really just going to be a 1. I usually just scratch that out. So we have a negative B. And remember, you're not allowed to have a negative exponent. So that is going to need to come to the bottom. So it'd be C to the power of 7 as our final answer. So what rules did we use? We use the quotient rule. We used the 0, which is power of 0. You guys might have to look at how you phrase these. There's a cheat sheet that I think your teacher gave you, Miss Palmer. So refer to that. And we use the negative exponents rule. Negative exponents rule. Could we have done this quicker? Yes. But I'm going to just have you guys do it this way. If you have a quicker method, but it yields the same answer, more power to you. Keep doing that. Okay. The next section is asking you to write equations in standard form. Now, what does that mean? Standard form means you have to start with the highest exponent. Write those numbers first. And then you go down to the smallest exponent or lowest exponent. So when we look at a question like this, the highest degree or highest exponent is x squared. So I'm going to say negative x to the second. Yes, you have to look at the sign that's right before that value. Minus 5xy plus 14y. The xy will take precedence because he has an x. So yeah, that would have to be it. Question 30. Highest degree here is x to the fourth. So we'll start with that term. So 2x to the fourth power. The next one down is plus 10x to the third. The next one is plus 4x. And then a minus 1. This one is already in standard form. So is this. Is that all we were doing? Oh, we're writing in standard form if needed, and then classify. I missed that second step. So folks, we have to classify the polynomial. So we classify polynomials by degree and by the number of terms. So if the degree is 2, this is quadratic. You guys have notes on this already. This is by degree, this is a quadratic. And it has 3 terms, 1, 2, 3 terms, which makes it a trinomial. So this is a quadratic trinomial. You always do degree and the number of terms. So here, by degree to the fourth power, that's called quartic. And it has 4 terms. So remember, if you have 4 terms, I think we said quadrinomial. But some of you told me that you guys, after 3 terms, you just say polynomial. So it could be that. Or we could say quartic polynomial. Both of these are correct. For those people who told me that you don't have to say the specific term after 3 terms, you can use polynomial. But for those people who want to be even more specific, use the term quadrinomial. That means you have 4 terms, 1, 2, 3, 4 terms. Okay, the next one. The highest degree is 3. That's called cubic. And it has 2 terms, binomial, cubic binomial. The next one, 1 term, and the degree is 1. So this is a linear, because degree is 1, and 1 term is monomial. Well, that completes that section, and this is straight up from your notes. So just study your notes also. The next section is requiring us to simplify polynomials. So let's go there. We're just adding polynomials. This is a matter of combining like terms. I'm noticing a squared and a squared right there. Just color code these real quick. And then I'm noticing a -6 and a 1 right here. And then I'm noticing a plain old -8a and a -6a like that. So we just combine like terms. And the answers must be written in standard form. That's what the instructions are saying. So let's start with the highest degree. 8a squared minus 7a squared. That's going to be 1a squared. So there's no need of showing the 1. It's okay. Just say a squared. It makes you look more professional. The next degree is the green, which is -8a minus 6a. So -8 minus 6 is -14a. And the last but not least are the constants. And those are -6 plus 1, which makes it a -5. So our final answer, I'm just going to make it one color so it's not so festive. You have a squared minus 14a minus 5. This 2 looks weird. Let me fix that. There you go. Now remember, when you're adding 2 polynomials, life is pretty straightforward. However, when you're subtracting, you want to be a lot more careful because this subtraction symbol is affecting all of these numbers after it, all the signs are going to be changed. The reason is you're distributing a 1, like negative 1 times 5. So this will end up being negative 5x to the second. This will end up being minus 2x plus 2x cubed plus 1. I'm just going to bring down the first one because nothing changed there. So 6x minus 7x squared plus 7. And now we combine like terms. Again, remember, just since we have to write this in standard form, why don't we just just do it now. We have 2x to the third as our highest degree. So I'm going to write that first, 2x to the third. That means we've taken care of this one. And then the next one on our list is 5x squared. So we have negative 7x squared. Sorry, negative 7x squared minus 5x squared. That's a negative 12x squared. That covers this one and that one. The next thing on our agenda is the 6x minus 2x. That becomes a 4x. So these are gone, taken care of. And then we have a 7 plus 1. So that makes it an 8. And there you have your answer. Oh, I forgot to box the one above it. Let me go ahead and do that. Okay. Moving right along. Still simplifying polynomials. This is multiplication. And again, always write your answers out in standard form. So this is pretty much distributing again. You take the 3y, multiply each of these terms in the second parenthesis by it. Once you've done that, you're going to come back and do the other guy. This times all of these guys. All right. So let's finish this. I'm going to use this color. 3y times y squared is 3y to the third. 3y times negative y is negative 3y to the second. 3y times 7 is 21y. And then negative 6 times y squared is negative 6y to the second. Negative 6 times negative y is positive 6y. Negative 6 times 7 is negative 42. And then, of course, you examine to look to make sure that you don't have any like terms. If you do have like terms, then you want to combine them, of course, right? So do we have like terms? We do have like terms. These. Okay, let me color code this again for you. We have the 21y. And that's about it. Let's combine those. So our answer will end up being 3y cubed. Negative 3 minus 6 is negative 9y squared. 21y plus 6y is 27y. And then you have a negative 42 at the end. And that is your answer in standard form. Good stuff, y'all. Keep going. So here we're once again distributing. So negative 3x times 5x, negative 3 times the 1. So this becomes negative 15x squared minus 3x as our first parenthesis. And then there's another one, 8 minus 2x. Now we're going to have to FOIL here. So we're going to take this times this times that. Once we've done that, we'll then come back and do this part. This times this times that. Let's do the orange ones first. Negative 15x to the second times 8 is negative 90x to the second. Negative 15. Oh, I'm so sorry. Negative 15 times 8 is not 90. My apologies. That should be 120, right? Yeah. Sorry, let me change that. This is going to be negative 120 x to the second. And then negative 15 x squared times the negative 2 is a positive 30 x to the third. And then let's do the purple ones. Negative 3x times 8 is negative 24x. Negative 3x times negative 2x is positive 6x to the second. Again, we're at the point where we need to combine like terms. Notice this guy here and that guy are both x squared, so those are like terms. We need to combine them. So, but it has to be in standard form. So I'm going to write the 30 x to the third first. Negative 120 x squared plus 6x squared is negative 114 x to the second. And then minus 24x. Standard form. Okay, question 37. This is x minus 2 to the fifth power. This, please don't make the silly mistake, the common mistake that everyone makes and thinks that says x to the fifth minus 2 to the fifth. Do not do that at all. That would be incorrect. What this is saying is we need to do x minus 2 times x minus 2 times x minus 2 times x minus 2 times x minus 2. But if you're thinking that's going to be incredibly difficult to do all this, to multiply all these binomials, you're right. There has to be a better method because it is near impossible to keep track. You would probably fill out this whole space and it would be a lot of work with a lot of room for making mistakes. Enter Pascal's triangle. This is why we were making Pascal's triangle to expand these binomials. And I'm going to draw it, the Pascal's triangle, at this corner here, so we have room to work the actual question out. Remember, it starts with 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. I'm stopping at 5, this row, because our degree is 5. So we need that last row. So that last row, remember, is these are going to be our coefficients. So we write them down, but we space them out. So I'm going to start with 1, 5, 10, 10, 5, and 1. And then remember what we were doing? We take this first item, the first term in this binomial is an x, and we start with that high. So x to the fifth, x to the fourth, and we bring it downwards. X to the third, x to the second, x to the power of 1, and finally x to the power of 0. And then we are going to take that second term, which is a -2. Yes, you have to keep that sign, folks. Very, very important. And because it's a negative number, you have to put it in parentheses. So that second term, you started low. So you started at 0, and it's going to keep going up. So to the power of 1, -2, to the power of 2, -2, to the power of 3, -2, to the power of 4, and finally -2 to the power of 5. The rest is just simplifying, just simple arithmetic. First things first, I like getting rid of anything that's to the power of 0, because that's just going to be a 1. So I'm going to scratch that out, and I'm going to scratch out the x to the 0 here at this end. The rest is simplification, folks. 1 times x to the fifth, oh, that's just going to be x to the fifth power. 5 times -2, so you have to do these digits first. 5 times -2 to the power of 1, so that's really 5 times -2, which becomes a -10, x to the fourth power. The next one, 10 times -2 to the second, so that's really 10 times 4, and that's going to be a positive 40, x to the third. And then next we have -2 to the third, that's -8. 10 times -8 becomes -80, x to the second power. And next, 5 times -2 to the fourth, well, -2 to the fourth is 16. 5 times 16 is 80, 80x. And then last but not least, we have 1 times -2 to the fifth. -2 to the fifth is -32. Is it 16 times 5 really 30? It is. I don't know why I'm having a hard time remembering that or figuring it out. Anywho, this would be the answer to the question 37. I know this is a lot, but you might have to pause this video, come back and try this problem again. Now, if you want to do more research and do more practice problems, you can just go to YouTube and type in binomial expansion and just watch some videos if you need more videos, or look at your notes. Alrighty, next question. Simplify the polynomial by dividing by a monomial, factoring, or a long division. Final answers should be written in standard form. Okay, got it, bet. So if you have a monomial, the best approach here is to really rewrite this by giving each one that denominator of that monomial. So 12r to the fifth divided by 4r to the fourth plus 4r to the third divided by 4r to the fourth plus 48r to the second divided by 4r to the fourth power. Now, just simplify each fraction individually. So starting with this, 12 divided by 4. Oh, that's just a 3, right? And then r to the 5th divided by r to the 4th. Remember, you keep the base. And the rule says if you're dividing, subtract the exponents. And you subtract 5 minus 4 will be just r to the power of 1. But if it's to the power of 1, is there a point of me showing the 1 there? I wouldn't even bother. Just leave it alone. Okay, go to the next one. 4 divided by 4. That's just going to be a 1, right? And then we have 3 r's up here and 4 r's on the bottom. So I can say these 3 r's cancel out and they cancel 3 r's on the bottom. So really we're left with an r on the bottom, 1 over r. I know that kind of looks weird. I'm giving you multiple ways of doing this. Let me just expand this and explain it a little bit. I'm going to expand this part here. R to the 3rd over R to the 4th, right? This is a different way of thinking about this. R times R times R is what the top is saying. The bottom, we have 4 of them. So what I'm trying to share with you guys is you can actually logically see that you have 1 up here and an R on the bottom. That's why we have this. Alternatively, remember the rule that says, oh, guess what? If you have 2 numbers that have the same base, the base is R, and they're being divided, you keep the base and you subtract the bottom one from the top one, which gives us r to the power of -1. But wait, we cannot have a negative exponent, so we have to fix that by moving it to the bottom. So it becomes 1 over r. Again, the same thing as this. So there are multiple ways of arriving at the same answer. I'm giving you different ways of thinking about this so you're better prepared. But if you have a method that works for you and you get the question right 100% of the time, well, stick to that. Here's the next question. 48 divided by 4, that's going to be a 12. We have 2 r's up here and 4 r's down here, which means the 2 r's up top can cancel the 2 r's on the bottom. So you'd have, oh, I forgot, you'd have a 12 over r squared. And that is the answer to this question. All right. All right. Oh, actually, wait, it did say write the answer in standard form. So because this one has r squared, let's rewrite this and have it at the beginning. So we would say this is 12 over r squared plus 3r plus 1 over r. I don't think you get dinged for writing it this way either, but just to be safe. Okay, y'all. Now, are we told to use any specific method? It just says use any method, huh? So what would be the best method for dividing this one? If I were you, we can use long division here. I know you guys are not fans of the long division, but we can use long division here. So I'm going to write it as x to the 2nd minus 7x plus 10. You can divide that into 9x minus 45. So folks, remember the goal is always to get rid of that first term. I'm not a fan of this at all, to be honest with you guys. Can we change this out? Let me make a suggestion here. I'm going to change strategies. I don't like the long division. If it's okay with you all, let's use synthetic division for this question. So let's change this to synthetic division. Now, when you're dividing by synthetic division, what you put out here, this number is you got to solve for x in this little divisor. So we have 9x minus 45. We need to solve for x, so set it equal to 0. Add 45 to both sides. So 9x equals 45. X ends up being a 5. That's what you're going to put out here as your divisor. Okay, and then in here, folks, remember we were filling this space with the coefficients of this equation. So the coefficients are 1, -7, and then 10. And as a reminder, if you're missing a power, like let's say we didn't have this, you would have to put a 0 there as a placeholder. Anything that's missing, you have to put a 0, just a reminder. This time we're not missing anything because it's x to the power of 2 to the power of 1, so we're good here. I'm going to bring back the -7 as it should be. Great. I hope you understand that. Once you've set it up, the first step is moving down. Just drop down the 1. The first digit, always drop it down directly. And then you always multiply these. 5 times 1 is going to be a 5. And then you're always adding downward, right? So it'd be negative 7 plus 5 is a negative 2. And now again, we're back to multiplying for the next one. 5 times negative 2 is a negative 10. Oh, and then again, you're adding these. 10 plus negative 10 really just cancels out. And I box out the last thing on here because that's like your remainder. And your these numbers are your new coefficients. So this new coefficient is x minus 2. Remember, when you divide, you're dropping the degree by 1. The degree used to be a 2. Oh, so it has to go down to just having a degree of 1, just as a reminder. So your answer to this question is x minus 2. That's done. So question 40, once again, I'm going to suggest that we use the synthetic division method again. So we draw the L. What in the world are we going to be dividing by out here? Remember, you take your divisor and you have to solve for it. So y minus 7 equals 0. Add 7 to both sides. So we're going to be dividing by is 7. And then the coefficients go here. So the coefficient 1, and then negative 7, and then negative 2, and then 18. We are not missing anything. Oh, we are missing something. To the power of 4, to the power of 3. Where's to the power of 2? That's missing. So we need to put a placeholder for the power of 2. We do have the power of 1, so that's going to be negative 2. And then we have the constant, which is 18. So then, as is custom, we're going to drop down the first digit right there. Let me write the 7 better. And you're going to multiply. 7 times 1 is 7. You're going to add these. You get a 0. 7 times 0, 0. 0 plus 0, 0. 7 times 0, 0. Negative 2 plus 0, it's negative 2. 7 times negative 2, negative 14. 18 minus 14 is 4. Again, always box off the last digit. This is your remainder. So now we got to write the new equation, right? Remember, after dividing, you drop the degree by 1. We started with a y to the 4th. So now the coefficients are 1y to the 3rd plus 0y squared plus 0y minus 2. But is there really a point of showing these? That's kind of silly for me to write this. I'm just going to eliminate those. And we're going to write the answer out as y cubed minus 2. Now, wait, sorry, we have a remainder for this problem. So here's what you do with the remainder. You attach it to your answer here. Since it's a positive 4, I'm going to say plus 4 over your divisor, which is y minus 7. This is the full answer to that question. Okay, so moving right along, folks. Given this equation and that equation, this is function notation. We are asked to find, we're given 3 equations, h of x, three functions. The first question is subtract f and g. Simple as that. You're going to take the function f, which is x squared minus 4x minus 12, and you're subtracting the function g. Now, because this is a subtraction, you want to be incredibly careful. You must enclose the second one in parentheses. Why? Because remember, this negative affects the signs in here. Had it been a plus, we wouldn't have cared. But because it's a negative, they're being subtracted, we have to really watch out for that. So here, we'll end up having negative 5x to the second plus 2. Then we'll have x squared minus 4x minus 12. I just brought this down because nothing changed. Now it's just a matter of combining like terms. X squared minus 5x squared, negative 4 squared. And then minus 4x is just by itself, so I'm going to bring it down. We have a negative 12 plus 2. That's a negative 10. And you are done with that problem. Simple as that. So just obey what this is telling you to do. That's inviting you to just subtract g from f. The next question is asking you to multiply h to g. H and g multiplied. So h is x plus 7. So I'm going to put that in parentheses because you're multiplying. And then g is 5x squared minus 2. So this is calling for foiling, right? So we got to FOIL this guy. this times this times this. And then once we've completed that, we're going to come back and do this times this times that. And then we're going to combine like terms if we have any. X times 5x squared becomes 5x to the third. X times negative 2 is negative 2x. 7 times 5x squared is 35. X to the second. 7 times negative 2 is negative 14. We don't have like terms, but we need to write this answer in standard form. So from the highest degree, followed by the second highest, third highest, and finish with a constant. And that, friends, is your answer to this question. Okay, this is the same idea, really, folks. We're being asked to now divide h and f. So function h is x plus 7 divided by function f, which is x squared plus 4x minus 12. So typically, you are supposed to simplify these if you can, but let's see if we are able to do that. So focusing on the denominator, is it factorable? Let's see. We can do a product. It's negative 12. Sum is what? 4. What multiplies to negative 12 and adds to 4? You might be thinking, oh yeah, 6 and a 2, but I would have to make the 2 a negative. So let's see if anything simplifies here. We have x plus 7 on top, but the denominator is x plus 6 and x minus 2. So nothing canceled out. Sometimes you find stuff canceling. This time it doesn't happen. That's why I was doing that. So I think you should check it to see if you can or not. So we could have left the answer here. But since we simplified, there's no harm in doing the simplification. So you're good. That's still right. Question 44, pretty self-explanatory. It's telling you to just add g to f, right? So you have 5x to the second minus 2 plus h of x is x plus 7. And because we are adding, we don't need to be careful here with parentheses. That doesn't matter. It only matters when you're subtracting because the negative affects everything. Here we only have two like terms, so let's go there. 5x squared plus x plus 5, because negative 2 plus 7 is 5. Done. Okay, so now we're getting closer and closer to the more challenging questions, or the more fun ones, if you like. You notice we have f minus g of negative 2. That's how you read this. F minus g of negative 2. This is a two-step process. You want to do f minus g first, which I believe we did up here. Did we not do f minus g? We did do f minus g. So we can literally steal this thing, but let's just rework it. And then once we have f minus g, we're going to plug in a negative 2 into it. So f is x squared. X squared plus 4x minus 12. Again, folks, remember, this is a subtraction. So you want to be extremely careful and put the second term in parentheses. You're subtracting g from it. So we're subtracting 5x squared minus 2. So let's open up these parentheses. Negative 5x squared plus 2. And here you have x squared plus 4x minus 12. I'm just bringing that down. Let's keep working this out. We have like terms. X minus 5x squared is a negative 4x to the second plus 4x. Negative 12 plus 2 is a negative 10. So that's this part. But remember, this is a two-step problem. Once you've done that, it's telling you, give me that of negative 2, which simply is fancy language for plugging negative 2 into all your x values. So this will be negative 4, plug into the net negative 2 squared plus 4 times negative 2 minus 10. Again, these are instructions. Do that first and then plug in the number next to it once you've done this, the first part. So using algebra, or just plug this into your calculator. This will be negative 4 times 4 minus 8 minus 10. So negative 16 minus 8 minus 10. Negative 24 minus 10 is negative 34 as your final answer. Okay, so again, like I said, we could have just taken what we already had done f minus g. See this part right here? We had already done that. let me prove it to you. I'm going to zoom out a little bit here. You see f minus g that we got from above. Oh, it's too far up. This f minus g is the same as that. Those are the same. So we could have not done the work twice. In fact, let's see. Have we done the next one? H over g? We haven't done h over g. I was going to just steal it, but we haven't done h over g yet. Anywho, let me zoom back out and put back in, I should say. Okay, so 46, h over g, we'll do this part first. And then once we've done it, we'll do the 4 next. Is it the only way to do it? No, there's another way to do it, but let's just do that because I think it made sense to you when we worked together. All right. If you're wondering what's the other way you could do this, rather than do h over g first, you could literally plug in f4 into h first and then plug in f4 into g first and then simplify those values. But let's just do h over g. All right, so h is x plus 7 over g, which is 5x squared minus 2. Now, it says once you've done that, plug in a 4 into all the x values. So this will become 4 plus 7 over 5 times 4 squared minus 2. Again, simple math, simple arithmetic here. What's 4 plus 7? The top is 11. 5 times 4 squared, that's 80. Minus 2 is 78. 11 over 78. So the way to write the answer out, actually, let me be honest, is h over g of 4 equals this value. That's really how I should write these answers. Do I think Miss Palmer would be upset if you don't? I don't think so. But to be safe, I'm actually going to fix 45 also. I'm going to write the answer in its correct syntax. So it should be f minus g of negative 2 equals negative 4. There you have it. Okay, so we're making good progress. The next section is still on function notation. And these are known as, just composition of functions. Sounds fancy, pretty simple. See how you have f of g of x? These are instructions. It says you're going to take the function g and you're going to plug it into f. Anywhere there's an x value, you're going to plug in that function. So let me show you this in a better way. So you're going to take these values, g of x, and you're going to plug them into every x into that equation. So that's what we're doing. So for this guy, where we have an x, we have replaced the x with a 4x minus 9. Since that's squared, because that's x squared. We replace the x with the 4x minus 9 squared plus a 4. And then we have to simplify this by saying, 4x minus 9 squared means we have to write it twice, because that's what you do when you square a number. And then we're going to FOIL it out. So when you FOIL this out, you will have this times this times this. So I'm trusting you guys remember how to FOIL, but that's going to be 16x to the second minus 36 minus 36. So that's going to be a minus 72x plus 81. I skipped a step because I know you guys know how to FOIL. If you don't know how to FOIL, go to YouTube and just Google how to FOIL. And I hope you know how to FOIL, because if we don't, we're in trouble. At this point in the game, we got to be proficient in foiling. It needs to be like a fundamental skill that we just know. All right, so we go to 16x to the second minus 72x. These are like terms, so I'm going to combine them. It's just going to be 85. So f of g of x is this answer. Good. All right, so let's move along, folks. You can write these composition in two ways. This is method 1. This is method 2. They mean the same thing. You can, these again, just like the instructions were to take the g and plug it into f, that's the same exact instruction here, but this time it's saying take h, dump it into g. So let me show you that. We're going to take h and we're going to dump it into g right there. So that's going to be 4. In place of x, we are putting in x squared plus 3x minus 10. And then there's a minus 9. This minus 9 right there. So let's distribute the 4. This becomes 4x squared plus 12x minus 40 minus 9. We do have like terms. So g of h of x equals 4x squared plus 12x minus 49, because those two combined give you a negative 49. And that's the answer, folks. Okay, let's keep going. The next section has the same style, same instructions, just one more step. It's like a 2-step question. And once again, I'm going to keep explaining this, folks, for those who need it. You take f, that's the instruction, plug it into g. And then once you've done that, you're going to take the negative 3 and you're going to plug it into that equation, whatever that's going to be. So let's do it in steps. So let's take the function f, this guy here. Oops. Take f, and we're dumping it into g, where there's an x right there. So we'll have 4, open parenthesis, x squared plus 4 minus 9. This is part 1. Okay, so then let's simplify it. So 4x squared plus 16 minus 9. That comes from me distributing this 4. And then we can simplify this further, because the 16 and the 9 are like terms. We end up having 4x squared plus 7. Now that's part 1. The second part was saying once you have that, we just did this part. Once you have it, then you plug in this negative 3 into it. So now we're taking the negative 3 and putting it in place of x. Okay, so 2 steps. So we have 4. Now we're plugging in the negative 3 in there, squared plus 7. This becomes, you can use your calculator for this. 4 times 9 is 36 plus 7. This becomes 43. But to write the answer in the correct syntax, I'm going to say g of f of negative 3 equals 43. I'm thinking you're okay if you just write 43, but I'm just being extra cautious here. Okay, so enter question 50. So if you see these nested ones, again, multi-step problems, work from the inside out. What this is giving you instructions to do, you're going to take 7, you're going to dump 7 into h. That's going to give us some number. We'll take that number and we'll dump it into g. So 2 steps. Work with me on this. Take the 7, let's dump it into h. So anywhere there's an x, we're putting in a 7 in this function right here. So we have 7 squared plus 3 times 7 minus 10. So we have 49 plus 21, subtract 10. This is going to be 70 minus 10, and that's going to be 60. So that's h of 7. We finished this part right here. So now this is a 40. We're taking the 40 and dumping it into the function g. So we'll take 40 and dump it in here. Sorry, it's not a 40, it's 60. Our answer was a 60, not a 40. My apologies. 60. So it'll be 4. Yeah, we're taking 60 and dumping it into g. 4 times 60 minus 9. So we have 240, take away 9. So our answer for g of h of 7 equals 200 and, is it 31? 31. Just 2-step process. Okay, now we enter into factoring, another exciting section or type of problem that we've been working on. So let's see. So many methods of factoring, but folks, I know you're tired of you hearing me say this, but the first and most important and the most basic form of factoring is looking for GCF. When I look at these two numbers, I can determine that they have a greatest common factor. What goes into both of these? A 2. 2 is a GCF, so I can take out a 2, which leaves us with a 16x to the 6th minus 49y to the 2nd. So once you take out a GCF, and you don't always have a GCF, you may not have it, but you should always look for it. Then there were other methods, right? We talked about using the X method. This is when you have, a trinomial that is, with an even degree. Then we talked about grouping. And we were using grouping when you have four terms. Then there are the special cases, like the difference of squares. We called it dots, difference of two squares. This is when you have a binomial with a subtraction and two values that have a square root, which is what we're looking at for number 51. There's a subtraction on this binomial, and both of these have a square root. The square root of 16x to the sixth is 4x to the third. The square root of 49y to the second is 7y. You guys remember this? I hope you do. So now, once you know that we have a dots, we know that we always have two parentheses. One of them always has a plus, the other one always has a minus. So now we just fill the blanks with the square roots that you just found. So this is 4x to the third and 7y. 4x to the third and 7y. And there's no place else to go. So that's fully factored. You may have to pause this and watch it several times. Again, if you find that you need more practice or more review, go to YouTube and type in difference of two squares or factoring difference of two squares. Then watch a couple videos there to be really proficient. Okay, so looking at the question 52, how many terms do we have, folks? 1, 2, 3, 4. And we just said if you have 4 terms, which method do we use? Use grouping if you have 4 terms. Okay, how do you group? Literally set each pair in its own parenthesis, like that. And now you focus on each parenthesis and you take out the greatest common factor. So for this first one, x squared is the greatest common factor, leaves you with an x plus 2. The second one, 5 is the greatest common factor, x plus 2. For those who have a really good memory, you may remember that you always want the two parentheses to be the same. Okay, if they're not the same and you use grouping, that means something went wrong. Go back and fix it. But since we are good here, all you do is see these two outside terms, you're going to put them in their own parentheses. So x squared plus 5 in its own parenthesis, and x plus 2. You just write down one of the two that are the same. And that's it. And I said plus 5, by the way, because this is a positive right here. Had this been a negative, then I would have said minus 5. All right. There are other factoring methods that I didn't mention up here. A fifth method of factoring that we looked at was sum and difference of cubes. Difference of cubes. When do you use this? When you have perfect cubes. These are numbers that have cube roots. And this is where, folks, we brought in SOAP and SMS to help us remember this. Okay, I only bring this up because question 53 needs it. I'm going to hide this 53 because it's sort of like in that way, and it's sort of like confusing, but this is question 53. Just know that I'm just blocking it out because it's not part of the problem. And I don't want you guys to get confused by that. So does x cubed have a cube root? If you've answered yes, you are correct. The cube root of x cubed is just x. Does 512 have a cube root? If you've answered yes, you are correct. And I think the cube root of 512 is 8. So this is a sum of cubes. Now, for those who may have forgotten, let me write down the sum of cubes up here, sum and difference of cubes. So let's say we have a cubed, something that has a cube root, plus another thing that has a cube root. We said, which is what we're looking at here. That's this example. We said it factors like this. It's always going to be a binomial then and a trinomial. Let's talk about the signs. We use SOAP to help us remember the signs that go in those parentheses. S stands for same. O stands for opposite. AP is always positive. So same sign. So this means it has to be a plus. Opposite, and then always positive. That helps you. SOAP is for helping you remember those signs. And then SMS helps you remember the second parenthesis. You have to square, multiply, square, square, multiply, square. But now that we've gotten this far, I want you to remember that the blanks, you take the cube roots and you put them in here. This is squared, multiplied, squared. So what I'm trying to show you guys here in essence, this is your A value and that's your B value. You've already found your A and B. So let's actually finish this question. We know that we have a binomial and we have a trinomial. It's a positive, so same sign, opposite sign, always positive. So this will be x and 8 squared multiplied squared, because 8 times 8 is 64. And that is the end of this question. You cannot go further. We're just being asked a factor, so we'll stop there. That's it. While we're at this, we've talked about the sum of cubes. What about the difference of cubes? A cubed minus b cubed. Again, same rule, a binomial, a trinomial. Same sign, squared, opposite sign, multiplied, always positive. Simple as that, folks. So now we're moving on to question 54. And we have 4 terms, which calls for which method, folks? 4 terms you use, grouping. So if you've said grouping, great job. Again, let me get rid of this 54 just so it's not in the way. It's not part of the problem. It's just the number of the problem. Okay, we've grouped. We have 4 terms used grouping. Take out the GCF in this first parenthesis. X squared is what they have in common, which leaves us with a 2x minus 3. Second parenthesis, we have a negative 32 and a 48. The GCF there is negative 16. So you have a 2x minus 3. Again, notice how my 2 parentheses are exactly the same as they should be. This 2x minus 3, same as that 2x minus 3. And if you're in doubt, you can just do a quick check. Negative 16 times 2x, that gives me the negative 32 that I wanted. Negative 16 times negative 3, that gives me the 48 that I wanted. So we know that it works. And the next step, remember, is just taking the 2 terms that are on the outside and giving them their own parentheses. So x squared minus 16, you put those together. And then you have a 2x minus 3. But folks, be careful, because it may appear as though you've finished the problem, but you haven't yet until you've examined to see if you can factor further. For those who have a keen eye, you'll notice, this can factor further. That's a difference of 2 squares, which means we can do the dots basically, which means open two parentheses, x plus 4, x minus 4. And then I'm going to bring down the 2x minus 3 because we can't go any further with it. That, folks, is fully factored. Now, while we're here, I'm just remembering that sometimes we're asked to factor and solve. So yeah, you would do the same exact thing. Solving, as a reminder, folks, we're not doing it for this problem, but I just want to mention this. You go one extra step. You set each of these equal to 0, and then you solve, which I'm pretty sure that might be the next section. Actually, let's just go there. Let's go there and see if that's what the case is. Well, yes, it's going to be in this section coming up soon. So now you know. Same idea. Just make sure you are taking that extra step. All right, so this question, we have to factor. Again, always look for GCF first. We do have a GCF. 6 goes in all of them, so I'm going to take that out. 8. And then you focus on what's inside of the parentheses. It's a trinomial and it's even. So this calls for the X method, folks. Product and sum. What multiplies to negative 8 and adds to negative 2. So if you've said 4 and 2, you're on the right track. But what signs do we need? 4 times 2 is a positive 8. We wanted a negative 8. 4 plus 2 is a positive 6. So we have to make this 4 and negative. Let's see if it works. Negative 4 times 2 gives us the negative 8 we wanted. Negative 4 plus 2 gives us the negative 2 that we wanted. So we know these are our terms. So now we can write this out. It'll be, keep the 6 that you factored out. It's part of your factors. And now your 2 parentheses will have x minus 4 and x plus 2. Those are fully factored. Okay, now we are solving these. Once again, solving, you have to set your equations equal to 0. So that's our first move. Let's move the x to the third to the left side. So I'm going to add x to the third to both sides. Our equation needs to be written in standard form. X to the third plus 5x to the second plus 6x equals 0. Now that we have the equation in the correct form, we can start factoring. Again, always look for GCF first. These three terms have an x in common, so I'm going to take out an x, which leaves us with an x squared plus 5x plus 6. Now you pause here again and you examine what you have. You go, wait a minute, I have a trinomial that is even. So yes, that calls for the x method. Product is 6, sum is 5. Product and sum. A times C and B, just for those who need a quick refresher. So what multiplies to 6 and adds to 5? If you've said 2 and 3, you are correct. So now we have the factors that we want. Bring down the x that you factored at the beginning. Don't lose your GCF. Keep bringing it down with you. And then now this becomes x plus 2 and x plus 3. However, remember, we were being asked to solve. So we have to then take the extra step, set each of your factors equal to 0. This one has 3 factors. This factor, and that factor. And each of these we'll have to set equal to 0. So the first one is pretty simple, x equals 0. Second one, x plus 2 equals 0. Third one, x plus 3 equals 0. To solve for x in these two, subtract 2 from both sides, subtract 3 from both sides. So now you have x equals -2. Here, x equals -3. So your 3 answers are x equals 0, x equals -2, and x equals -3. 3 answers. Question 57. Change the color here for contrast a bit. Okay, this is a difference of 2 squares. So we have to factor first. Remember, with the difference of squares, you get 2 parentheses. One's a plus, one's a minus. X plus 6, x minus 6. And you're solving, so you're going to set each of these equal to 0. X plus 6 equals 0. X minus 6 equals 0. Just use algebra because you've done this so many times. I'm kind of breezing through this. Subtract 6 on the first one, add 6 on the second one. So boop, boop. X will ends up being -6. Here, x ends up being +6. So your 2 answers are this and that. Next question. You have 4 terms. So which method should you use here, folks? If you've said grouping, you are correct. But first, I feel like we should take out a greatest common factor. Always look for GCF first. And I'm just realizing that all of these have an x. So we should really just take out the x first. That's the GCF. So that gives us x to the third minus 5x. Ooh, it's actually out of order. So first things first, this thing is out of order. It's not in standard form, so be careful. So I'm going to bring this guy here, and then this guy's going to come over here. So it'll be x to the third, and then this here will be minus 4x squared, which makes this guy here minus 5x plus 20 equals 0. Yeah, so that was sneaky. Y'all be careful, folks. So now we go, great. You've taken out the greatest common factor, as we should. That's what we always do when you have, an expression. An equation that you're trying to solve for. Take out GCF. And then once you've taken out GCF, examine what's left in the parentheses. So we have 4 terms. I'm going to group these 2 together and group those 2 together. Don't forget that the x, the original GCF that you took out, don't forget it. Usually I draw an arrow so I don't forget it and just have it down here. So that way I'm not dragging it with me the whole time. I just don't want to forget it. I'm going to put it out there. So the first parenthesis, this one right here, we look closely and you go, oh, we can take out a GCF for those guys. They have an x squared in common, which leaves us with an x minus 4. The second parenthesis, these 2, have a -5 in common, which means we can have an x minus 4 left. And now to see these 2 outside terms, we put them in their own parentheses. So we end up having x squared minus 5. And you bring down one of these, so it's x minus 4. That's fully factored. But since we're solving, we have to set each of our factors equal to 0. So the first one is this one. So x equals 0. That's done. The second one, x squared minus 5 equals 0. The third one, x minus 4 equals 0. Then we got to solve for these. So for this one, I'm going to add 4 to both sides. So the 4's, of course, cancel. So we end up having x equals 4. The second one, I'm going to add 5 to both sides. So now these cancel. We have x squared equals 5. But we don't want x squared. We just want x. So you have to square root. And we end up having x equals plus or minus square root of 5. So we have 4 answers to this question, as we should have had 4 answers. Why? To the 4th power means we should have 4 answers. Well, what are those answers? You probably are asking. X equals 0, 4, and plus or minus root 5. Those are the 4 answers. 1, 2, 3, 4. That would be your answer to that question. Okay, on to the next one. We're going to keep working through these. Again, always take out the GCF first. Big rule. The leading coefficient should never be a negative number. So what you want to do here is, why don't you take out a -1 to force this to be a positive? So this becomes x to the 3rd. And of course, that's going to affect all the other signs also. So change the signs for all of them. In fact, let me pause here. Let me see. I just see they have something in common. They have an x in common. So let's take out a negative x, actually. That leaves us with a positive x to the 2nd. Change the sign to -4. You took out one x, so it's -4x. Change the sign, so it's going to be a -21. You took out the x, so that's it. And you, of course, you want to pause here and examine what's inside of the parentheses, right? Here. It's a trinomial that is squared. So the x method makes sense. Product and sum. Product is -21. Sum is -4. Right? So we know that we can factor, we're looking for numbers that multiply to -21 and add to 4. If you're thinking 7 and 3 with a -7, you would be correct, because -7 plus 3 is -4, -7 times 3 is -21. So this becomes -x, x minus 7, x plus 3 equals 0. You're setting each of your factors equal to 0, so that's going to equal 0, x minus 7 equals 0, and x plus 3 equals 0. Now you've got to solve for each of these. This first one, divide by -1, because there's an invisible one here. This second one, you're going to be adding 7. Third one, you're going to be subtracting 3 from all. So look, here. Our final answers are as follows. Those are gone. X equals 0, x equals 7, x equals -3. You can write the answers like this, or just like in the previous problem, you can just put them in one straight line, like x equals -3, 0, and 7. Whichever one you prefer, either one's fine. Okay, question 60, very similar to the previous question. Do we have a greatest common factor? The answer is yes. X in common leaves us with x squared plus 8x plus 16 equals 0. So this part is factorable, right? So x, again, use the x method. At this point, I'm just going to keep going. It's x plus 4 and x plus 4, because you guys know how to do the x method now. Oh, notice these two are exactly the same. You don't have to solve for both of them, honestly. So we'll set each factor equal to 0. And since the x plus 4s are the same, I'm only going to solve for 1, right? So I'm going to subtract 4 from both sides. These cancel. So x equals 0 and x equals -4. For those of you who may be wondering, what about the other one? This is where the multiplicities came in, folks. If I have two x plus 4s, I could say the answer is x equals -4 with a multiplicity of 2, because there were 2 of them. This would be x is equal to 0 with a multiplicity of 1, in case you're wondering. But, there you have it. Did the question, did these even state the multiplicity or not? Let's actually look at that. No, factor, solve. It didn't. But in case you're wondering, that's where the multiplicities came in. Okay. Now here we are determining if each divisor is a factor using synthetic division. Here's how you know that something is a factor. If your remainder equals 0, then you know that that divisor is a factor. So let's set this up, synthetic division. Once again, remember, you got to solve for it, this thing. So it'll be -5. The coefficients are 1, 2, -22, -45. Always drop the first number first down. So it goes down here. Then you multiply. -5 times 1, -5. Then you add 2 minus 5 is -3. -5 times -3 is 15. Then you add these. -22 plus 5. I believe that's -7. -5 times -7 is +35. When you add these, you get a -10. Oh, so sadly, we did not get a remainder of 0. That's neither good nor bad. It just means that x plus 5 is not a factor. That's your answer. Or you can just say no. Had we gotten the remainder of 0, then the answer would have been yes, but we didn't. We got a -10. So there you have it. And that's what we're going to do for the rest of these. I'm going to change the color here so it's not so monotonous. Instead of the synthetic division, 1 goes on the outside. 1, 2, -5, 3, -1. Drop down to 1. Multiply, add. So here you get a remainder of 0. So the answer to this would be yes, because we got a remainder of 0. Here, repeat the same process. Synthetic division. 2 goes here. 1, 5, -14. Drop down to 1. Add 0. Oh, I guess we got a remainder of 0. So you would say yes, x minus 2 is a factor. Here, it's kind of getting boring at this point, right? So bear with me. 1, -3, 2, -4, and 4. Drop down to 1. Multiply, add. Remainder is 0. So this would be yes. Okay, this is, notice here, we're missing a bunch of terms. We don't have x to the second. We don't have x to the power of 1. So we need placeholders. Just as a reminder, -1. So we have a 2 and -1. We're missing x to the second. So I'm going to put a placeholder. We're missing x to the power of 1, putting a placeholder. And then we do have a constant as a 4. So drop down to 2, multiply, add these guys. -3. Oh, yeah, this becomes a -3. -1 times -3 is a +3. The remainder here is a 7. So this is no, not. Okay. The next portion is asking you to find all the solutions of this equation given that x plus 5 is a factor. Sure, not a problem. Here's what you do, folks. You start off by using synthetic division. So we put in -5 out here because of this. Then the coefficients are 1, 5, -3, -15. Drop down the first digit. Multiply, add, multiply, add, multiply. The remainder is 0. That doesn't surprise us because we knew that this was a factor. We were given that. Now, if you want to find all the solutions, you now have a new equation here. Remember, these are your coefficients. So this is now x squared plus 0x minus 3 that you need to solve for. These are your new coefficients. And remember, when you divide, you came from x to the third, you drop the degree by 1. So that's why we have an x squared. By the way, is there a point of me writing 0x? It's kind of silly, right? So when I eliminate that, and what we really have is x squared minus 3 equals 0. We have to solve. It says find all the solutions. So that's why I'm setting it equal to 0. And we can solve this using the square root method. So let's just add 3 to both sides to that, right? So what's going to happen? X squared equals +3. And now we can square root both sides to get x by itself. So we end up having x equals plus or minus the square root of 3. So the solutions to this are -5 that came from what we were given when you solve for x. And then we now have plus or minus √3. We should have had 3 answers because x to the third. And we do have 3 answers. Here's the first one. And then here are 2 answers, positive √3 and negative √3. Okay. Next question, very similar to the previous question. We're given two numbers that are solutions. This time we don't have to solve for them because, let's just use one at a time. We'll start off with, the one, I guess. And then the coefficients of this guy, which are one. Oh, we're missing x to the third. So placeholder. We have x to the second is a -9. Oh, we're missing x. That's a 0. And we have the constant. So we were missing a bunch of things here. That's why we have those zeros there as placeholders. Drop the 1, multiply, add, multiply, add, -8, multiply, add, multiply. So this ends up being a 0, which we knew because, we were given that's a solution. So we've spent this one already. So now we repeat this using the other thing that we were given, which is a -1. We're going to continue the synthetic division. So I'm going to just continue it here. Now we have a -1 on the outside. We're using the second one now. Okay, so drop the 1, multiply, add, and then multiply again, add, multiply again. Again, that's a remainder of 0, right? Good. So now we've spent the 1, we've spent the -1. We want to find all the roots. So remember this, each time you've divided, every time you've divided, you have brought the degree down. So we started to the 4th power. This is when we divided the first time, it brought us to the x to the third. The second time, we now add x to the second. So these are the coefficient. We now have x to the second plus 0x minus 8. But again, 0x doesn't make sense to have here. So I'm going to rewrite this as x squared minus 8 equals 0 since we're solving. And to finish this, of course, you're going to solve for x using the square root method. Add 8 to both sides. These are going to cancel. X squared equals 8. And then you got to square root both sides, right? Square root and square root. And we've already done how to, square root these guys, but it'll be x equals plus or minus. The square root of 8 can be simplified to 2 root 2. How? Square root of 8 breaks down to, 4 times 2. Oh, 4 has a square root, so that's going to hop out. The square root of 4 is a 2, root 2. That's how we got this answer. Now, since we are being asked to write all the roots, we got to list all the roots. So the first answer, the ones that we were given were -1, comma 1. Those came from the question. They were given those as roots. And then we just found two others, plus or minus 2 root 2. 4 answers, which we should have had 4 answers, and we do have 4 answers. Okay, y'all. Well, we have just 2 more questions. Bear with me here. We are almost done. Okay. Then we've got find the other zeros, given that -1 is a 0. So again, starting off with the synthetic division, -1. Coefficients are 1, 2, -1, and -2. Drop down to 1, multiply, add, multiply, add, multiply. The remainder is 0. So now this brings us to x to the second plus x minus 2. Now we try to solve for this using, it's a trinomial that is squared. So we're going to try using the x method. What's the product? What's the sum? Product is -2. Sum is 1. What multiplies to -2 and adds to 1? If you're thinking 2 times -1, then you'd be correct. So now we know that we can factor this guy to x plus 2 and x minus 1. Since we're solving, you're going to set each of these equal to 0. So you've got to subtract 2 from both sides, add 1 to both sides on the second one. And then these cancel, so x ends up being -2. These cancel, x ends up being a +1. So all the zeros would be x equals the -2, -1, which you were already given over here, and 1. I like writing them in order from the least to the greatest, but there you have it. Last but not least, folks, for this question, we are given that x minus 1 and x plus 3 are factors. So if you're going to use this in the synthetic division, remember you have to solve for each one. So this we'll have to use, a 1. So we'll be dividing by a 1 in the synthetic division for this guy. And here we'll be divided by -3. It'll be 2 back-to-back synthetic divisions. Well, let's set them up. You've got here. Let's start off by dividing by 1. this will be x equals -3. So let's divide by 1 first. It doesn't really matter where you start, but I'm just going to decide to do this one first. So the coefficients are 1 and 1, -11, -9, and 18. Drop the 1. Then you multiply, add, multiply, add, multiply, add, multiply, add. The remainder is 0. But that comes as no surprise to us because we knew that we were told that those are factors, so we knew they would work. Now look at the second one here, which is the -3. That's the one we're going to divide with next. I'm going to put it over here. Now we're dividing this by -3. Again, drop the 1, so multiply, add, multiply, add, multiply, then add. Again, the remainder is 0. That should not come as a surprise because, again, we knew that was a 0. So here's the new equation. These are the new coefficients. We started at x to the 4th. We've divided twice. So the first division brought it to x to the 3rd. The second division has brought it to x to the 2nd. So this is 1x to the 2nd minus x minus 6 equals 0. A trinomial that needs to be factored, well, x method. So let's do the x method here. What multiplies to -6 and adds to -1? If you're thinking 2 and -3, you'll be correct. Those are the factors that we're going to be using. So this factors to x plus 2, x minus 3. Since we're solving, you're going to set each of these equal to 0. X plus 2 equals 0, x minus 3 equals 0. To solve for this, you're going to subtract 2 from both sides. You're going to add 3 to both sides. So you end up having x equals -2 and x equals 3. So to write the final answer here, just find all the zeros. I'm going to say x. I'm going to list them all. So I'm going to write them in order from the smallest one to the greatest one. You don't have to do that, but I like doing this. So the -3 is our smallest one. Then we go to -2. Then we have a 1. And then we have a 3. Those are all the answers that we have. X is 1, -3, 2, and -2 and 3. And that, friends, completes this review. Hang on, let me see if I can restart my camera. Oh, I can. There we go. Okay, folks. So that brings us to the end of this review packet. However, remember that this is not limited to just these things. There is this other unit, the last unit that we were working on with characteristics of functions and behavior, like intervals of increase and decrease. Those aren't on this packet. But since it's so recent, the idea is you have them in your mind because you actually have a test. You just took a test on this. So they should be pretty fresh on your mind. Remember that you do have your respective teachers available to you during the review sessions, like the review days, and also before school and after school. So thanks for following along. And just feel free to reach out to those teachers or just refer back to this video as many times as you need. Thank you for being awesome students this semester. I wish you a very Merry Christmas and a Happy New Year. I will see you again in January. Take care, folks. Adios.